Given polynomial p of x equals negative 2x cubed minus x squared plus x, find the sketch of the polynomial with all the intercepts and the ends. Okay, solution? Well, the problem is this is not factored. We're going to need to factor this polynomial. So I notice that each of these three terms, negative 2x cubed minus x squared plus x, share a common factor of either x or negative x. I'm going to pull out negative x as a common factor because that way my first term that's left over, it'll be positive and easier to factor. It's 2x squared plus x minus 1. I'm going to factor that either by guessing or by the diamond method, negative x times 2x minus 1 times x plus 1. Now, to find the roots represented in each of these factors, you set each of the factors equal to 0 and you solve. For the first factor, negative x, we get x equals 0, together with set 2x plus 1 equal to 0 and set x plus 1 equal to 0. Solve each of those for 0, and you'll get x equals 0 together with x equals 1/2 together with x equals negative 1. Those are actually called our roots. Those x values are our roots, also called our zeros of the polynomial. Now, the degree of the polynomial is the highest power on x. We'll look at the given form at the very top. That's a third degree polynomial, which means it has an odd degree. The lead coefficient, the number multiplying the highest power of x, is the number, the number negative 2. So the lead coefficient is negative. So we have odd degree with a negative lead coefficient. It gives us this type of end behavior. To the left, we're going to be going up. To the right, we'll be going down. That's our ends. Let's make a table involving the zeros or the roots. List all the zeros here, the multiplicity of the root associated with that zero, the factor. Then is the x-intercept a cross or a kiss, and what is the x-intercept? First, we look at the root or the zero, x equals 0. Okay, what is the multiplicity of this? We'll look back at the factored form. This root, 0, corresponds to the factor negative x. And outside of negative x, there was the invisible first power. So this is multiplicity 1, which is an odd multiplicity. That indicates our x-intercept is a cross, and it's represented by the ordered pair 0, 0. Okay, the next root we found above was x equals positive 1/2. Now that was involved in the second factor, which was 2x minus 1. And the power outside the 2x minus 1 was the invisible first power, which means multiplicity 1. It's an odd multiplicity, indicating the x-intercept will be a cross. And the x-intercept is listed as positive 1/2, 0. The last value, the last root, is negative 1. And we found that in the factor x plus 1. So the power outside of that factor was 1. It's a 1 multiplicity, which is odd. That means it's a cross at the ordered pair, negative 1, 0. Let's find the y-intercepts by evaluating p of 0. The y-intercept is equal to, let x equal 0, you'll get p of 0 equals 0. So the ordered pair, 0, 0, is our y-intercept. Now we're going to do a pre-sketch info. We're going to find out the behavior on the left and right side immediately of each of the roots. And we'll do this with our sine graph. We're going to do the x-axis, draw the x-axis, and each of the roots. 0 is a root, negative 1 is a root, 1/2 is a root. So divide the number line according to these roots. Now the y-axis will divide it because 0 is a root in this particular problem. Negative 1 is a root, so we have a dotted line, and 1/2 is a root. So we have divided the x-axis into 1, 2, 3, 4 regions with our 3 roots, our 3 zeros. We're going to list the factors on the left. They are negative x, 2x minus 1, x plus 1. And down below, p of x, which is the product of all of those factors. Now, we're going to choose a value to the left of x equals negative 1. Let's say x equals negative 100. Plug it into each of the factors for x. Plug in negative 100. For the first factor, you get negative of a negative 100 is positive 100. That's positive. For the second factor, 2 times negative 100 is negative 200 minus 1. That's definitely negative. And for the last factor, negative 100 plus 1 is still negative. Multiply those together to get the sign on p of x. a positive times a negative is a negative times a negative gives me a positive p of x. Now, for the region between x equals negative 1 and 0, we'll choose the x value, let's say negative 1/2. So in the first factor, minus negative 1/2 is a positive 1/2. In the second factor, we have 2 times negative 1/2 is negative 1 minus 1 is negative. And the last factor, negative 1/2 plus 1 is positive 1/2. So we've got a positive times a negative times a positive. Multiply them together, the entire polynomial is negative. In the region of x values between 0 and 1/2, let x equal 1/4. Plug it into the first factor, you get negative x, which is negative 1/4. So that's a negative value for the first factor. Let x equal negative 1/4. 2 times 1/4. 2 times 1/4 is 1/2. 1/2 minus 1 is negative 1/2, so that's negative. For the last factor, 1/2 plus 1 is positive. Multiply a negative times a positive, and you'll get the entire polynomial as a positive. Now finally, for the values of x greater than 1/2, let's let x equal, say, 100. Plug it into the first factor. Negative x means negative 100, that's negative. Second factor, 2 times positive 100 is 200 minus 1 is positive. Last factor, 100 plus 1 is 101, that's positive. Multiply them together to get the sign on the entire p of x, it's positive. So we see here that the polynomial, the y values in other words, are going to be positive in the first region, negative in the second region, positive in the third region, and negative in the fourth region. And what that means is, in the first region, the sketch on the left of negative 1 is going to be above the x-axis. Between negative 1 and 0, the sketch will be below the x-axis. Between 0 and 1/2, because it's positive, the sketch will be above the x-axis. And to the right of 1/2, the sketch will be below because of that negative. So now we're going to draw the polynomial, the y-axis, the x-axis, list all the roots, negative 1, 0, and 1/2. So those are our x-intercepts. Our y-intercept is at 0, 0 also. And we don't know how high or low it goes in between the zeros, but we know it's above the x-axis here, below here, and above here. It's a rough sketch. It's not perfect, but not too shabby.